Hello students, I welcome you all to my session. So today I'm going to do exercise 1.3. We are actually doing chapter 1 number system. We have already finished exercise 1.1 and 1.2, and if you have not watched it, please go back to the playlist and watch them first. Also, you can click on the I button for the other exercises. So let's start. Today our topic is rational number. See this rational number in the decimal form. When you talk about decimal form, there are two types of decimal form. One is terminating. We'll talk about this in detail, and the other is non-terminating, repeating or recurring. So first let's understand this terminating. What do you mean by terminating? See if I take any example. Example C, 625 divided by 5. Okay, what you will get? You will get 125. So this ending, the result is ending. Okay, so this is called terminating decimal. Okay, example 2c, if I divide 10 divided by 3, I'll get some number like this, 3.333. see, this is non-ending. Okay, it will again repeat. If you want to see, I can show you here. 3 divided by 10, see, 3 3 is a 9, 1 point here, 0 I have to take, as you know. 3 3 is a 9, again 1 point is already there, so I can take 0, again 3, again 9, 1 point is there, so I can take 0, again 3 times, again 9. So like this it will keep on repeating. Okay, it will keep on repeating. So I'll just put dots. So 10 divided by 3, I'll get 3.33333. so this is non-terminating. It is not ending. Non-terminating is non-ending, so it's not ending. At the same time, see, this 3 is repeating. Okay, so what is this decimal form will be called as? This will be called as non-terminating. Okay, it's not terminate, means it is not ending, and at the same time it is repeating. The digits are repeating after decimal point, repeating, or it is also called recurring. Okay, I hope you understand. So today our topic is rational number, which can be classified as terminating decimal form, and the other decimal form, it can be termed as non-terminating, repeating or recurring. We have seen the example. This is terminating, this is non-terminating. I hope you understand. So rational number. Let's also see irrational number. Let us also see the irrational number. What is the difference between rational number in decimal form? In decimal form, see, I am getting terminating, this is stopping, and here non-terminating, but it is repeating. Number is repeating after decimal point. Number is repeating. What about irrational number? Let's see the irrational number. Let's see the difference between these two, rational number and irrational number in decimal form. See the definitions, we have already known rational number and irrational number. Okay, but here specifically we are seeing rational number and irrational number in decimal form. For example, same, let's take example 1. See, this root 23, if I divide this, I'll get, if I take out the root, I'll get 4.79, like this number I'll get. See what I'm getting, this is non-terminating, it's not ending, I mean non-terminating. Okay, and also non-repeating. Okay, so you have to be very clear about these 2 points. This is non-repeating. Similarly here, pi, as we know, pi 22 by 7, if I divide, I'll get, see, this decimal form. This is again non-ending, okay, or non-terminating, and non-repeating. It's not repeating. The decimal after point, after digit, see this point, numbers are not repeating in some pattern. See, numbers are repeating, obviously. See, if I tell you, see this 9 is repeating, 3 is also repeating. I'm not thinking about that repetition. I mean to say some pattern. If you go back to rational number, see here, some pattern is there. After digit 3, okay, 3, 3, 3, some pattern, it's following some pattern. In irrational number, numbers are repeating, same. This 9, here also 9, here also 9, but it is not following any pattern. Okay, so irrational number are non-terminating, non-ending in decimal form. I meant to say, in decimal form, it is non-terminating, non-ending, or also non-repeating. See, numbers are non-repeating in some pattern, non-repeating or non-recurring. So I hope you understood the two major differences between terminating, sorry, between rational number and irrational number. In rational number, there are two types, okay, two conditions. One is terminating. Simply, if we divide some number by some number, suppose 10 by 2, I'm getting 5. So this is my rational number. This is terminating, stopping. I mean, there is no continuation of any other numbers. Other condition, non-terminating. See, if I divide, it is also non-terminating. So this is common in non-terminating, is common in both rational and irrational number. In irrational number also, it is non-terminating. But what is the difference? In rational number, the numbers after digits following certain pattern of repetitions, but in irrational number, the numbers are not repeating in some pattern. So that is the difference. I hope you understand between these 2 points clearly. Okay, so if you understand, please look, let's go to exercise 1.3 example 1. And what is the example 1? This is the example 1. Okay, what you have to find? So this I have taken exactly from the book. Write the following in decimal form. Okay, in decimal form. Can you see it? Let me zoom it for you. Okay, okay, can you see now? Write the following in decimal form and say what kind of decimal expansion each has. So question number 1, 36 by 100. Question number 2, 1 by 11. Question number 3, 4, 1 by 8. Question number 4, 3, 13. 2 by 11, 5, 6, 3 to 9 by 400. So we'll try to do maximum number of questions. Is it clear? So let's try number 1. So number 1, what is the questions? Number 1, it is 36 by, so solution number 1, it is 36 by 100. See, this I'm not going to divide at all, because you have to understand the concept also, how you divide this 36 by 100. So simply answer I can put, say, 2 zeros in the denominator, 1, 2. This is shortcut method. I'll show you the long cut method also, but you should know at the same time shortcut method. Sometimes you need to know. So there are 2 zeros in the denominator. So how you do? Just let me write the numerator value first, 36. So from right hand side, I'll just put point before 2 digits. Before that, I can put 0. So your answer will be 0.36. Okay. So your answer is 0.36. So this is your, please tell me now, what is this? What is this? What is this? This is obviously terminating, ending after digit, point or digit. There are 2 digits after decimal point. There are 2 digits and there are no other more digits. So this is ending. So this is rational number in terminating. Okay. So first condition, terminating. So what I'll write? The decimal expansion is terminating. terminating. I don't think you'll have any question on this. This is very simple, because if you see, your question was write the following in decimal form. See, I have written in decimal form, point should be coming. So decimal form, and say what kind of decimal expansion each has. So this decimal once I divide 36 by 100, I'm getting 0.36, and I have to also say what kind of decimal expansion this one. So this is terminating. So question number 1 is finished. So let's go back to question number 2. Question number 2 is 1 by 11. Okay, let's do question number 2. Question number 2 is 1 by 11. So this too you have to do. Okay, still I'll show you, no problem. I can show this also. How to do this? Let's do it for you. 11 and this one. Okay, let's take here. Now see, this 11 I cannot divide 1 by 11. So what I have to take? What I have to take? I'll take here, see 0. Okay, I'll take here point. For this point, I'll take 1 0 here. For this point, I have taken point here, so I'll take 1 0 here. Again, this 11 is not going. I cannot divide 10 by 11. No, this number has to be greater than this number. So in that case, what I'll do, please try to understand this. First, I cannot divide, so I have taken point, and for that point, I have taken 0, 1 0. Again, what I'll do, again I'll take here 0 and here 1 0. Two step to be understood here. In many questions, in many people have done many ways, but I'll show you the shortcut way and the way which you can understand easily and which you can remember forever. So first, you cannot divide 1, so take 1 0. For that, 1 point, 1 more 0, take 0. Now I think you can divide 11 by 9. 99. Is it okay? So I can take here 9, because 9 11s are 99. Same process repeats. See here, from 10 1, I'll get again here 1. Same process follows. Again 11 will not go, so what I'll take 0 here. Point I'll not take again, only one time. Okay, here I'll add 0. Again it's not going, so 1 more 0. Okay, so again 9 11s are 99. Is it understood? Okay, so let's take again one same method follows. Okay, I'll take 2 zeros. You can take 2 zeros at a time, because it's not going, so I'll write here 0. Once it's not going, so I'll write 0. I have taken 2 zeros. Again 9 times, so 99. Again repeat. Okay, 2 zeros. I'll take here 0. Again 9 times, 9 11s are 99. So like this it will keep on repeating. So that means what? 1 by 11 I will get 0 0.09. Okay, 0 is 0 9 0 9 0 9. Non-repeating. This is my non-terminating. It is non-terminating because it's not ending. Okay, or in other words, I can say 0.09 then I can put here 1 bar. That means 09 is repeating. Okay, so decimal expansion. What about the decimal expansion? See, when I divide these two, I'm getting decimal point, decimal expansion, and this decimal expansion is non-terminating because it is not ending. So the decimal expansion is non-terminating and repeating. Okay, repeating, non-terminating, repeating. Okay, because it's not ending, therefore it is called non-terminating, and this also repeating. 09090 is following some kind of pattern, so repeating. Is it okay? If okay, then I can go to next questions. What was the next questions? Let's see the next questions. Question number 3 is 4 1 by 8. Okay, 4 1 by 8. Let's do this one also. 4 1 by 8. Number 3. 4 1 by 8. This type of sum you have already done in the earlier classes. If you have this type of sum, what you have to do, you have to multiply this 4 with the denominator and then add the numerator. Means 4 is a 32 plus 1. Okay, that means what you do, 4 into 8 and then multiply plus this 1, the numerator, multiply the denominator with 4, then plus, take the numerator whatever value we have. Here I have 1, so I have taken 1, and then you put this divide sign by the whatever you have in the denominator. You have in the denominator 8 equals to 4 is a 38, sorry, 4 is a 32. What I'm saying, 4 is a 32 plus 1, 33 by 8. If you divide this again, see what you get. Okay, so let's divide this also. Okay, let's divide this also. 8 33. Okay, so how you divide? See, this 33 I can divide by 8. How many times? 4 times. 4 is a 32. I'm getting 1. Now see, can I divide this 1 by 8? Obviously not. If I cannot divide, what I take first point, I mean decimal point, not 0. First you take decimal point. Give one chance to this question first by taking, see, when you take decimal point here, you get 1 0 free. Take that 0 here, big 0. Okay, for point, decimal point, 1 decimal point, 1 0 free. And you check this 8 and 10, yeah, it's going one time. If it doesn't go, suppose see, after taking here 10, if you cannot divide this 10 by some other number, for example here 11, in that case, here again it could have taken 0 and one more 0 here. Is it clear what I want to say? If this 11, if this, instead of this 8, if you have 11 and here 10, so what you would have done, you would have taken here 0 and 1 0 here, because after decimal point you can take, if it is not dividing one more time, that means you can take 0 here again, but you have to put here 0. So first decimal point, then 0. So we'll forget it for the time being. So 8, yeah, it's going one time, 8, then here 2. See, now what happened? Now what happened? You have decimal point, so all the time you will get 1 0 free. Okay, so 8 2s are 16. Again 4. One decimal. See, actually, here, question number 1. Okay, I'll show you this. See, here was the same thing happened. See, 1 0. See, this for this decimal point, you have 1 0 free, and for this 0 I have taken 0, so here 0. Similarly here also, okay, for one decimal point 0 is free, 10, okay, this is 10, and 11 is not going. So what you do, you take 0 here again and 1 0 here free, again 99, again 1. For this decimal point, this 0 is free, again 11 is not going, means you cannot divide 10 by 11. So what you do, take 0 here, 1 0 here, and also 1 0 here. Okay, 99, then again 9 times. So this means, what I want to say is that whenever you have taken this decimal point, 1 0 is always free, and if it doesn't go, all after taking 0 free, if you see that in this question you have seen, if it is not dividing further, like if after taking 0, for example here, no, it's like this, no, let me show, no problem, or let me show here one more point. See here, so for decimal point, 1 0 will be free, okay. See, still that 11 is not dividing, okay, still that 11 is not dividing. I have 11, see 11, this 11, this 10 is not dividing. So what I'll take here 0 and here 1 0. Now 9 times, 9 nines are 99. Is it clear? That means for one decimal point you can take 0 free. So here for this one decimal point I can take 0 free. So 8 and 40 if we divide, you'll get 5. So 8 5 is a 40. So this is also terminating, isn't it? This decimal expansion, after I divide 8 and 33, what I'm getting after I divide 8 and 33, okay, this 33 and 8, I'm getting 4.125. so that what I'll write the decimal, therefore the decimal expansion, the decimal expansion is terminating, okay. Is that clear? You want me to show one more, or will it be okay? Because we have many. Okay, let me show one more. I'll show you question number 5. Okay, I'll show you question number 5. What is question number 5? 2 by 11. 4 you can try. 4 and 6 you can try yourself. Will it be okay, or you want me to show all? Let me do this first. 5, question number 5. So let's start this. 2 and 11. Let me do here 11 and then 2. Okay, first what you do, take point, decimal point, and for this decimal point you can take 0 here, one decimal point, 1 0, and now you try 11 and 20. Yes, I can divide one time, 11, and before this decimal point you can take 0, no problem. See, if we minus it, you'll get 9. Again you have decimal point, so for that you'll get 1 0 free, 11 and 90 divide 8 times. So this is 88. Again 2. Okay. So again this decimal point 0 is free. Whenever you have decimal point 1 0 will get free. And if you check, see 11 and 20, can you divide? Yes. If you could not have divided, then again you could have taken 0 here and one more 0 here. But here now you can divide 11 20. It's going one time at least. So 11. So this is 9. Okay. So again this decimal point here. So one more 0 here free. 11 and 90 again 8 times. 88. 2. So this is again repeating. Again I'll get 20. Again I'll get 1. So here what is happening? That means if I divide, therefore I can write here 2 by 11. I can write here 0 0.1818. This is here. Okay, dot this will keep on going. Next line I can write 0 0.18, and above 18 I can put bar because 18 is repeating. It is following certain kind of pattern. 18 18 18. So 18 is repeating. So the decimal expansion you can write, the decimal expansion is non-terminating. This is non-terminating because it's not finishing and also repeating. So please write it. The decimal expansion is non-terminating, repeating. Is it okay? Okay, you want me to show the last number, example 6? Let me do this 6 also for you. You only try one, okay, which I have not done it. So question number 6, let me do this for you also. 329 by 400. So simple. I'll divide 329 by 400. I'll divide this 329 by 400. Okay, so 400, can you divide 329 by 400? No. So for that, what you take one decimal point, and before that you can put 0. Okay? 0, why? Because it's not going once. 0, why? Because it is not going. Okay, so 0. So for this decimal point you can take 10 free. 10 free. Now you divide 3290 by 400. Okay, so you just see here 400 into 8, so 3200. That means it's coming near to this 3290. That means I can take 8. Okay, and this is 3200. Again, if I subtract, I'll get 90. For this decimal point, I'll get 10 free. For this decimal point, I'll get 10 free. So 400, again it will go 2 times 800. Okay, so this, if I subtract this 2, I'll get 100. Now my question is, tell me please, all of you, 400, can you divide 100 by 400? Obviously not. So what you will do? Tell first what you will do. Because of this decimal point, I'll get 10 free. 3 idiots, huh? Free. So 400, now I can divide, it will go 2 times again. $800. Nah? Then here it will be 200. Can we divide now 400, 200? Obviously not. What you will do? Very simple. I have one decimal point, so I'll get 10 free. Huh? 3 idiots, huh? Very nice. So free, huh? So now you can say that 400 and 2000 can be divided, and I can divide it by 5. Means if I multiply this 5 and 400, I'll get 2000. So this is what? Therefore, 329 by 400, you'll get oh 0.8225, and this is ending. I'm getting the final answer. There is no more continuation, so this is terminating. So the decimal expansion is terminating. Okay, the decimal expansion is terminating. Done. Let us quickly do question number 2 also. Example 2. So this is the question which I have taken exactly from book. What is the question? Example 2. You know that 1 by 7 is this one. Okay, that means if we divide 1 by 7, you'll get like this pattern. Okay, 1 by 7, if we divide, you'll get 0.14. Okay, if we divide 1 by 7, you'll get 0.142857. This is the bar. What is the meaning of this? That means after this, again, you'll get repetition of the same numbers. That means you'll get 142857 again after this. Again after this, you'll get 142857. Again after, if you keep on dividing, again after that, again one more 142857. So this is a rational number, and the decimal expansion is what? Is it terminating or non-terminating? This is obviously non-terminating. That's why the bar is here. So okay, so what you have to find? What you have to find, that 1 by 7 is given this value. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? See, question is so long, but the answer is very short. I'll show you very easy method. Okay, so let's continue this. So your answer will be solutions. What is the first question? Can you predict what the decimal expansion? Yes, I can predict. Why not? I can predict, yeah. What is there? Yes, I can predict. We can predict the decimal expansion. Yes, we can. Same thing, you can, same line. We can predict. We can predict the decimal expansion. Yes, we can predict the we can predict the we can predict the decimal expansion of the given numbers, whatever the numbers given numbers without actually doing the long division. Okay, without actually doing the long division method. Okay, division method. But how? Let's do this also. How you can do this? Okay, so we have 1 by 7 is equals to what I can write. 1 by 7, it's given 0.142857. On the top of this bar is there, that means all these numbers are repeating. This is the decimal expansion is non-terminating repeating. Okay, therefore what I can write, 2 by 7 I can write like this, 2 into 1 by 7. Is it clear? No, 2 by 7 I can write 2 into 1 by 7. This is same as this, 2 ones are 2 by 7. So what you do, simply put the value. 2 into 1 by 7 is what is the value of 1 by 7 given? This is given. So put the value of 1 by 7, that is 0.142857. Okay, so what is the value you'll get here? What value you'll get? So you multiply this two. Okay, see this 2 and this 7. 2 into 7, I'm getting 14, so I'll take 4. No, this 2 and this 7, I'm getting 14, I'll take 4. I have 1, I'll use it later. 2 and 5, 10, and then plus 1, 11, so I'll take 1. Again I'll carry 1 later. 2 8s are 16, then 1, 17, carry 1, I'll take this one again. 2 2s are 4, again 1, 5. Okay, 2 4s are 8, 2 1s are 2, and then this decimal point, and then before that 0. So this is the simple method of doing this one. Okay, is that clear? First one, let's do the second. Similarly you can find 3 by 7. 3 by 7, what is this? 3 into 1 by 7. 3 into, what is the value of 1 by 7? You can take this, 0.285714. Again multiply, same method. What you will do? What you will do? 3 2s are 3 4s are 12, 3 1s are 3. Simple multiplication. Yeah. 3 7s are 21, carry 1. 3 5s are 15, 16, carry 1. 3 8s are 24, 25, carry 2 now. 3 2s are 6, plus 2, 8. So this is my answer. 0.3 by 7, 0.4. Something is wrong. Yeah, what is wrong? I have taken this value wrong. Something is wrong. Yeah, I'm so sorry. So sorry. This value 1 by 7 is not this value. Yeah. Let's correct it. Okay, it's my mistake. So 1 by 7 is this one, 0.142857. So multiply 3 7s are 21, 3 5s are 15, carry 2, 7, 3 is a 24, carry 1, 5, no, 3 2s are 6, 5 7 1, yeah, 3 is a 24, carry 1, 25, 3 2s are 6, carry 2, 8, it will be 8, na? Carry 2 be 8. Okay, this will be 8. 3 2s are 6, and from here carry 2 was there, so 8. 3 4s are 12. 3 1s are 3, carry 1, 4. And before this 0 point, this one. So you can put bar on top of this. So this is your 3 by 7. Okay, so let's quickly do the other one. What about 4 by 7? Same. 4 into 1 by 7. 4 into 1 by 7. 4 into, take the value of 1 by 7, that is 0 0.14287. So you multiply this again. This is the bar. This is the bar. So same method. 4 sevens are 28. 4 5 is a 20 to 22, carry 2. 4 is a 32, 34. Okay, 4 2 is a 8, carry 3, 11. 4 4 is a 16, 17. 4 1 is a 4, and 1, and you get 5. Okay, then before this point, and then 0. So this is your answer. Okay, let's do the other one. 5 by 7. 5 by 7. Okay, 5 by 7. Let's do this. 5 into 1 by 7, that is 5 into, what is the value of 1 by 7? Again 0 0.14285. This is the bar. So multiply this. After multiplying this, you will get 0 0.714285. Okay, and the last one, that is 6 by 7. 6 into 1 by 7, that is 6 into the same value, 0 0.14285, and the bar is there. Okay, don't forget this bar. This bar means these numbers are repeating. If you multiply, you get 0 0.85714. So this is the answer. So I hope you understand. The next video I'll show you example 3 4 5, whatever is left I'll show you in the next video. So keep on watching all my videos. Thank you so much.